Let us start the discussion for the binomial distribution. Now, this type of distribution of probabilities is applicable to only those events which have two possible outcomes. So, any given event A, suppose, must have only two possible outcomes. In that case, we can consider or apply binomial distribution to such an event. For an example, let us consider tossing of a coin. So a coin is tossed. So obviously it has only two possible outcomes, namely either we get a head denoted by H or we get a tail denoted by letter T. Now suppose this coin is tossed multiple times. Such an activity has a peculiar name. It is called as Bernoulli trials. So if an event which is having only two possible outcomes is repeated n number of times, such repetition of that event is called as Bernoulli trials. Now for this case of a coin, let us take an example where the coin is tossed 5 times. The coin is tossed 5 times. And suppose that we are asked to find out what is the probability that we get exactly 3 heads. Now for this problem, one can easily construct the sample space and then check for those events and count the number of such cases which correspond to exactly 3 heads, and then we will be able to find out the corresponding probability. But what happens if suppose this event is conducted large number of times? Then practically it is not possible to construct such a sample space. So for this we are going to use the techniques learned in the previous lectures, namely the principles of combinatorics and fundamental theorems of probability, even if we are going to discuss a coin tossed only for 5 times, because we at a later stage need to generalize this result to get a formula for binomial distribution. As discussed earlier, there are only two outcomes, namely head with a 1/2 probability and tail again with the equal 1/2 probability. Now we are asked to find out the probability for getting exactly 3 heads. So out of 5 tosses, if 3 are heads, the remaining 2 are obviously going to be tails. So just denote the event or the probability corresponding to the event under consideration as P, and let us denote the other event, the other outcome of the event by letter Q. So P represents the probability of the event of our interest or the outcome of the event of our interest, and Q represents the probability of the other possible outcome. In this case, both P and Q are equal to 1/2, but this may not be true in general. So in general, the values of P and Q are going to be different. But remember that always P plus Q has to be equal to 1, since there is no possible outcome left other than corresponding to P and Q, and total probability must be equal to 1. In this particular situation, out of 5 tosses, if we are supposed to get 3 heads, it doesn't matter. So it doesn't matter what order we get. What order we get. That is, we can also have HH, HTT, HTT, HH, and so on multiple times. So all these events count as getting 3 heads. There is a slight correction. One extra H has been written. So since the order does not matter, effectively we have to choose 3 heads out of 5 tosses. So this can be done in C5-3 or 5 choose 3 number of ways. So this is the number of ways of getting 3 heads out of 5 tosses. So the corresponding probability fx is going to be C5-3 multiplied by the corresponding probability P for getting 3 heads raised to the number of heads multiplied by the corresponding probability Q raised to the number of tails. So this can be solved to get C5-3 1 by 2 raised to 3 1 by 2 raised to 2. This can further be simplified in order to get a number for f of x, which is going to be the probability for this particular event of getting 3 heads when we toss 5 coins, or a coin 5 times to be precise. Now just look at this equation and we can straightforwardly generalize a formula for fx. Suppose x is an event and p is the favorable event, which is required event, or which is the event corresponding to the question asked. Q is the other event, or the probability corresponding to other event. Now suppose n is the total number of trials, that is the total number of Bernoulli trials, and x is the number of trials corresponding to p, corresponding to probability p. Then obviously for probability q, the number of trials left is just n minus x. Correct. So out of these n trials, x corresponding to p, so the trials corresponding to q are just the subtraction of n and x. So just look at this equation. Since we are writing 3 here, we are writing 2 here. This 2 can be written as p raised to 3, q raised to 5 minus 2. Now this 5 in this case corresponds to n. This 3 in this case corresponds to x. Sorry, we have 5 minus 3 here. So if we replace the numbers by the corresponding symbols, f of x would be cnx, cnx, p raised to n, q raised to n minus x. This is what is called as binomial distribution. Binomial distribution. Now using this formula, we can also define the cumulative distribution. Cumulative distribution, which is the sum of the probabilities up to a certain value, by writing it as capital F of x, as we have used capital F as the symbol for denoting cumulative distribution, as summation of u running from 0 to some allowed value x, c nu, p raised to u, q raised to n minus u. So these are sum of x terms starting with f of 0, plus f of 1 and so on up to f of x. So u takes values from 0 to x, which gives the cumulative distribution. Now we can see that this coefficient or this value of this value of the probability corresponding to a binomial distribution appears to be the coefficient of expansion corresponding to p plus q raised to n, right? And the expansion of p plus q raised to n is given by binomial formula, and hence we have labeled this type of distribution as binomial distribution. Let us consider an example to further understand this. So since we have with us the formula c nx p raised to n q raised to n minus x, let us take an example of throwing of a die. So a die has 6 possible values starting from 1, 2, 3 up to, or let us just write it, 4, 5 and 6. So there are 6 possible values which a die can give. Now suppose a die is tossed 5 times, and we are asked the probability to get exactly 3 aces. Now an ace is nothing but the value 1. So this event talks in terms of only 2 possibilities. Either we get an ace, that is we get the value 1, or we do not get an ace, that is the remaining values which a dice can give. So this is our P and this is our Q. Now this is only one possible outcome out of the 6 outcomes. So value for P is just 1 by 6. That is the probability of getting an ace. And the value of Q is 5 possible outcomes of the total number of outcomes. So value of Q is 5 by 6. In our case, N is 5 since the dice or the die is tossed 5 times. And we have been asked to find out the probability of getting exactly 3 aces. So out of these n equal to 5, x equals 3, because we are asked to find out the probability to get exactly 3 aces. So yes, we have the values of p, q, n and x with us. So f of x would be f of 3 in this case, which is given by c5 comma 3. Just note the formula here. Yes, this is the formula. C nx, so c5 3, p raised to n, which is 1 by 6 raised to 5. Oops, sorry, there is a slight correction. We have p raised to x here, right? Let us just look at the other terms. Yes, there is correction required as well here. P raised to x, right? Yes, it is mentioned correctly here. So p raised to x, that means we have p raised to 3 and q raised to n minus x, that is 5 minus 3. So f of 3 for this particular example is c5 3, 1 by 6 raised to 3, 5 by 6 raised to 2. Now this can be further simplified, but we are not going to do that. Just keep it as it is. This was regarding the binomial distribution. Now there are 2 theoretical topics related to this, namely Chebyshev inequality and law of large numbers, which are of theoretical nature, purely theoretical, which have already been discussed through the notes. So we will not be considering this in the video. In the next video, we will be discussing the normal distribution or Gaussian distribution, which is very well known in the area of physics and statistics. Thank you.